Hello, everybody, and welcome back to the Azure podcast. I'm your host, Evan Vasilik, and today is August 24th. This is episode number 436, and we'll be talking about Kestrel and how why it matters in the world of app services with our special guest Byron Tardif. And actually, nobody else is here today, and I don't have any news, so unfortunately for Byron, that means we're going to get straight to him. No break, you just go straight in. So Byron, why don't you start out, sort of tell us who you are and what you do here at Microsoft.
Of course. Hello, my name is Byron Tardif. I'm a principal PM manager with the app service team. Roughly working at Microsoft for about 13 years. I was a consultant in the industry before that. But I've spent most of my time on the cloud, worked several products. I shipped the first version of Service Bus. And then around that time, I switched over to App Service, and I've been with App Service team ever since. Multiple different areas that I've touched, including like how do we do deployments, how do we get our bits on the cloud. Mm-hmm. The first version of the API, back when we were talking about RDFE, which is the predecessor to ARM.
Yeah, sort of V1 basically for Azure.
Yep. And then, moving up the stack from that, I own all of the UI, UX for web apps, container apps, function apps, static web apps. Mm-hmm. And on that's kind of like my right brain, and my left brain is all of the Linux workloads on App Service. So
okay, App Service has a ton of breadth, right? At the end of the day, that does a lot. It's actually, you mentioned function apps. Function apps is basically sitting on top of app services, right? So there's a lot of interplay there, right? It really is a platform on its own these days.
Right.
So the reason, sort of, let me go back for the audience, just sort of how this conversation got started. Earlier in the year, y'all were in the process of making some changes really to the underlying infrastructure for app services. And, there was an investigation that I was involved in and sort of ran across this. And then from there, we sort of dug into, okay, what is this thing that we have done? Let's just start right there. So this change is Kestrel. It's an open source .NET Core thing. What is Kestrel, and why does it matter to start with? Like, what is it, and why would you ever care about it in an app services world?
Right. So Kestrel specifically is a modern implementation of a web server. So
like when IIS, WebSphere, things like that.
Exactly. Okay. When, like today by default, when you create a .NET app that is going to be talking over HTTP, the .NET process itself hosts the Kestrel web server, and that's what exposes the ports and does all of the handling. So if you're like old Windows, side of the house,
like HTTP and whatnot,
HTTP.sys and a W3P process, app pools, all of that stuff, right?
Okay.
And it's not tied to Windows. It is open source cross-platform, right? So when you're running .NET on Linux or on your Mac, it's the same Kestrel that is, instantiated in any one of those. So that's like one of the benefits, right? That it is the same no matter where you're running it. And then the other part is YARP, which is yet another reverse proxy. Another foundational piece of .NET that is replacing or allowing you to replace some of the functionality that existed in IIS through ARR, which is the application request router.
Yeah. Something like that. Yeah.
So those are like pieces of .NET, right? But what does that mean in the context of app service? That's kind of like the next logical question. And to do that, I'm going to have to go a little bit into the anatomy of the service just to help people understand where this all fits. So we do have a blog post that it was published originally to the App Service Team blog, but now it's also on the
we'll definitely blog. Link to it for the audience.
We'll add a link. The benefit of that is that it has some images that helps you, like block diagrams of
Mhm.
what are we talking about? But I'll do my best at painting a picture here.
Okay.
So you think of Azure, and that is a collection of data centers that exist across multiple countries, multiple geographical regions,
Mhm.
and that is kind of like the first level of abstraction, right? When you
Mhm.
draw a little cloud and you say that my app is talking to Azure, that's kind of it.
Mhm.
Uh, uh, the next level is saying, okay, so there's an Azure region. So an
Mhm.
Azure region is a physical location in space. It's sitting somewhere, but it actually represents one or more data centers. So in some cases, what you see as an Azure region in the portal is really broken down into 2 or 3 multiple buildings
Yep.
physically,
Yep.
right? And then we go deeper into that, and we talk about app service being one of the services that exists within Azure. I think, I'm going off the top of my head, but I think the last time I looked, there was something, over 270 services
Some
on
big
Azure.
number these days. Yeah, and
Some
there's
big
new ones
number,
every
yeah.
day. Yeah.
But I'm going to brag a little bit. Not every service is the same as every other service. App service happens to have a designation of XXL. And we only share that with 2 other services in all of Azure. So you can think of the big kahunas in terms
You're
of
talking
how
sort of like
much
the number of instances deployed and the number of customers using it, like the sort of indication of size, right?
the amount of infrastructure that exists within each data center that is dedicated to this
Okay.
particular service,
Gotcha.
right? So you can think of there's compute. Obviously, if
Mhm.
you're running raw VMs, there's going to be a ton of those dedicated to that. There's storage, right? If you have a storage account or anything that is going to blob, there's going to be a bunch of dedicated infrastructure for that. And then you have app service, where
Mhm.
we're going to have a bunch of dedicated infrastructure that is for app service workloads. Um, so we're zooming in, right? We're going
Mhm.
from Azure to a region to a data center to a service.
Okay.
Now, app service was built 12 years ago. I think we celebrated our 10-year GA anniversary this year in
Yep.
July.
Yep. Yep.
So when we started, the building blocks that were there were cloud services. So that's the V1 pass of Azure. And obviously, over 10 years, the footprint has evolved, but we still have a split of a good chunk of app service resources are running on cloud service infrastructure and architecture, and the more modern stuff is running on top of VMSS.
We actually had Christina Campi on earlier in the year to talk about
Yep.
App Services V3, right, which is the new
Right.
native ARM implementation at that point. So yeah, so the audience should
Right.
be reasonably familiar with that.
Yeah, and if we can do a quick plug here, is one of the key things that the team is working on is moving all of that infrastructure out of cloud services into
Hmm.
VMSS. So we're trying
Hmm.
to get that homogenized, if you will.
Hmm.
And that's a multi-year project. We're dealing with capacity and making sure that, again, it's the pains of being a double XL service is we need to make room for ourselves.
Yep.
Um, okay, so we have cloud services, and within a cloud service, there's certain limits of how big of a service can you build, right? There's,
Hmm.
we all think about the cloud scales infinitely, but in reality, there's some limits.
Hmm.
In our case, I think we're limited to something like 5,000 cores per cloud service or per chunk
Only
of cloud service.
5,000.
So
I mean,
only
only, yeah.
5,000, yeah. Uh, what that translates to is app service has this concept of a unit of scale that we call stamps.
Hmm.
So basically, we and this is a term that I think we borrowed from
Storage uses it as well. So does
yeah,
compute. Yeah.
SharePoint.
Yeah.
I think it originated from SharePoint, where when you were creating a SharePoint deployment on premise, you needed to have at least this many computers, and that was called a
Hmm.
stamp.
Hmm.
Because you think about it as you're rubber
Yeah.
stamping, and you're
They
just
should all be
basically
copies of each
creating
other, basically. Yeah.
another one, right?
Mhm.
So when we create a stamp, we usually start small and then we inflate it, right? So we get it until we start hitting the limits, then we need to create another stamp. What that means is that, across Azure, across all of the different regions and data centers, we have thousands of stamps. Some of them are multi-tenant, meaning that, you might get a dedicated VM for your app, but you're sharing infrastructure.
Mm-hmm.
Or you might have a dedicated stamp, and that's what you were talking with Christina about the app service environment
Yeah.
and app service
Okay.
environment v3, right? So that's
Okay.
what we consider a dedicated stamp. So now we're going into what does a stamp look like, and the stamp has multiple roles. So one of them happens to be this thing called the front end role. The front end role acts as a load balancer. So you start on your browser, you make a request, DNS magic happens, and your bits eventually get routed to Azure, and then Azure decides what is the right data center that needs to get mapped to, and then it hits the Azure load balancer, and then it goes and it says, okay, this is a request for something that happens to be hosted on app service. I'm gonna throw it into the right stamp of app service, and then that's where it hits the front end. And the front end, like I said, is shared infrastructure when you're in a multi-tenant scenario, or it's dedicated infrastructure when you're in an ACE. But you can think about it as there's a bunch of VMs that are getting these requests that then need to be forwarded to the VM that is hosting the customer's application. And that is the piece that basically got reworked. To put it in context, the app service front ends are dealing with, I'm going to look at my cheat sheet because it's like some stupid number, over 160 billion requests per day.
Wow. Okay. That's
right.
not
So
a small number.
it is, when I say it's a critical infrastructure
Yeah.
piece, it basically, if anything happens here,
Yeah.
we're knocking down thousands of customers, right? So it is a very critical piece. When we started, the app service team basically grew from IIS. We had a bunch of people that were working on IIS back in the day. So we used a lot of the stuff, including myself. I was PM for the, what was it called? Application server role.
Mm-hmm.
So we used a bunch of the pieces that we were familiar with, like IIS, ARR, to build that front-end role. And the front-end role has the responsibility of getting the request, figuring out what is the right VM that is hosting the customer's code, and then forwarding that to that particular worker. It does other stuff like TLS termination, offloading, etc.
It's basically acting as the proxy at the end of the day, but
Right,
to the stuff that's behind it. Okay.
right. So we ended up with a bunch of homebrew code that is like unmanaged HTTP.sys, stuff on IIS.
Mm-hmm.
So Brian, it sounds like the front end is Windows, right? But even though
Right.
the actual app may be not on Windows, is that how you think about it?
Yeah, that is correct. As of today, the front ends are running on a Windows box, and it doesn't matter if you're hosting Linux code or bring your own code, bring your own container. It doesn't matter. It's just a transparent proxy, right?
Thanks.
So yeah, so what happens is, at some point we need to start modernizing that infrastructure. And one of the benefits that we were looking at is all of the perf work that was done in .NET 6 specifically, to include the performance, because this is critical, right? We're talking about 160 billion requests per
Mm-hmm.
day. If we can make it, even 0.01% faster,
Makes a difference.
there's benefits, right? There
Yeah.
it compounds and it adds up. So that was one of the motivations. The other one was just the ability to have that open source and bigger ecosystem of that exists within the .NET community, right? So we were able to, from the team, contribute code, get changes from the community in, and basically have those pieces that are moving a lot faster than a Windows update would, right?
I think I remember, and I may be wrong on this because it's been a few years, but like I think I remember hearing from somebody early on that ARR did a really good job for what it was supposed to do, but it was not something that was taken up and used by lots and lots and lots of customers, right? It was sort of a niche thing within IIS. If you needed it, you needed it, but it just didn't get the same. It wasn't beat on and tested and used in all these places by thousands and thousands and millions of customer scenarios versus what Kestrel, what you're talking about, like it is the .NET Core web component. So now you're getting the benefit of everybody anywhere using Kestrel for anything. If they find something wrong, you're getting the benefit now versus before it really was just what you guys were finding at the end of the day.
Yeah.
But on the flip side, I would say is that HTTP and things like that are, tried and trusted C++, low level machine language implementation, right? And I don't know, Kestrel seems to be like, .NET Core or so. I have to ask, I mean, I'm sure you may get to it sometime, like, how do they how does the performance compare and things like that? I'm sure you'll get to that later.
Right. Yeah. So, we can talk performance up front, which is we saw an 80% improvement.
Improvement, not
without optimizing code. Right. So
wow.
we were doing one of the key things is what is the most compatible thing that you can make a piece of software, and that is bug level compatible, right? So that even things that you consider bugs continue to be bugs in the replacement, because something that is a bug for you is actually a feature for somebody else. That's a reality, right?
Yes.
When you have the wide spectrum of different levels of compliance within the clients of how they interpret the HP spec and stuff
absolutely.
like that. Any slight changes in behavior are echo through the platform, right? So we did some targeted tests, and that's what we found, right? So 80% improvements on the throughput, and without code optimization. So that's kind of like the next step of the journey is looking at what things we can do, keeping the compatibility, but looking at actual perf optimizations.
Right.
How do you get from? I mean, you said I think the number was 160 billion requests a day. If you're getting 160 billion requests a day, you don't just go just rip out ARR and IIS and just drop it in Kestrel. It'll all work, right? All 160 billion requests will go fine. How, at the scale at which you're operating, how do you make that shift?
Right. So before I get into that, I did want to talk a little bit about some of the other benefits of HP.sys versus Kestrel and .NET Core and unmanaged code versus managed code. The reality is that when we found a bug in our front ends, we needed somebody to go and attach a debugger and take like a OS level dump to go and then analyze that and figure it out. And the number of engineers that are qualified to do that is not the world. Whereas on the managed code side, there's a lot of tooling and there's a lot of things just built into the .NET framework that simplify that a lot. You don't have to parse through. I think the memory dump goes from being multi-gigabyte to just a couple megabytes. It's scoped to the stuff that you're actually interested in, and it makes it a lot easier to pinpoint what the issue is.
So just easier debugging, really, at the end of the day.
Right. Yeah, it comes down to expertise in unmanaged code that is like system level unmanaged code versus managed code. It makes a big difference when you need to support a service like this where you can have pretty much any engineer go tackle the problem. Okay, so what was the thing that I needed to backtrack to? How do we do the swap?
Yeah, how'd you do the switch from ARR and IIS to Kestrel?
Yeah, so
beyond very carefully.
Yeah, I think I threw an analogy on Twitter about the this equivalent to swapping an engine on an F1 car while it's still,
Yeah.
lapping around, and any analogy that I throw is going to break down at some point.
Mhm.
But in reality is we do have all of those different scale units. And when we do a deployment, we need to follow something that's called SDP, which is Safe Deployment Practices. And you can think of it as, thousands of scale units get distributed amongst about 6 different rings. We start with ring 0, which goes to something that is called EUAP, which is the Early User Access Program, where we have a special set of customers that actually pay additional money to be part of this program, where they get to test the next version of a release, right?
This is sort of like Windows Insider, but for Azure,
Right.
conceptually.
Right.
Okay.
And it's for people that have mission critical applications. You can think of, if you're a Fortune 500 company that you have, if your app goes down, it's going to cost you tens of millions of dollars a day. You want to be in this type of programs, and they get to suffer that in those particular regions or stamps that are a pinpoint for this EUAP thing. And they're literally our partners and telling us, hey, we noticed this change of behavior. We noticed this thing broke, or this thing got better or worse, and there's like constant communication there. So that's kind of like the first safety net, if you will. The other thing that we have is we have the ability to basically the way that the front ends got Frankensteined is that they could run in dual mode. So we could flip a switch and say, okay, run with the old behavior, which is the IAS and ARR, etc., or switch over to the new Kestrel+YARP infrastructure.
And without really doing a deployment to do that, right? It's setting a flag somewhere and that flips it. Okay.
Can somebody explain this term Frankenstein to me? I'm kind of new to it.
So it's literally, putting things together that probably should not be put together for real scenarios.
All right, I wouldn't have guessed. Thank you.
Yeah. As we move forward, and you need to think about it. It's I think we're starting to build features on top of this. So, for example, this work enabled us to do gRPC. And as more and more dependencies are building on top of this new infrastructure, it becomes harder for us to go and say, yeah, we're going to revert back to the old behavior. And that's where we slowly start, cleaning out the code and out with the old, in with the new. And now you have front end that is just Kestrel+YARP and no more IIS, HPCs, etc.
It is, I mean, at a high level, without getting into sort of specific numbers, when you and I first started talking about this, you were just sort of really early on this transition. And I think when we've been going back and forth about when's the right time to have you on the show. Now that you're on, part of the reason we decided to have you on is because the vast majority of app services is now running on top of on Kestrel. It might even be 100% now. But basically, you are running on Kestrel if you're running in app services these days, functionally.
In the same blog that I referenced earlier, we have the graph where you can see how we slowly took it to 100% over, give or take, a 6-month period.
Yeah.
I think I do need to put a little asterisk on 100%. I think there's one customer in one very specific region where we still have it flipped.
Yeah.
Because of some very niche thing that was affecting them. So we're waiting on this particular customer to make a change so that we can flip the bit and have it be really 100% across the board.
So it's like 99.99, however many nines.
Yeah, exactly. Long tail of nines.
Yeah.
But for all intents and purposes, if you're running an app, whether it's an old app or a new app, whether it's running on the cloud service or the VMSS footprints, your requests are going through this new code path. And then, all of this is, interesting from an engineering perspective, but what is the what is the customer benefit, right? What is
Yeah.
the,
Yeah.
what's
Why
in it
do
for
it?
me,
Right.
right?
Yeah.
Yeah. So, we touched a little bit about the benefits that we get from an engineering point of view of easier debugging, easier management, better perf. Something that people brought up is that this actually contributes to having a greener data center footprint, because if we're able to reduce the number of front ends that we need to host the same workloads,
Oh, yeah.
it's a fringe benefit. The reality is that we run over provision for the sakes of surviving spikes and heavy traffic and stuff like that. But even if we can take one or two front ends
Makes a
out of
difference.
rotation from every stamp, it makes a difference, right?
Yeah.
So there's that, but then it also enables us to build new features for customers. The first one that we're talking about, just because I think it was our number 2 most requested feature in the App Service Ideas Forum. We can throw a link to that if people don't know what it is. The Ideas Forum is where you as a customer can put in requests for features, and then other customers can upvote them. And we actually have a process where every month we review, we look at the ideas that are getting traction, and we use that to feed our 6-month planning process to find things that we should be investing on. Sometimes the reality is that it takes multiple years to enable that. Like gRPC, we had to do a major lift to get to a point where we could enable the feature. But it is something that we constantly look at and are trying to find ways to address those top asks.
Okay.
Following up on that, so some of the new features that are coming, we call them out in the blog, so I feel free to talk about them a little bit.
Darn, there goes our scoops again.
Yeah, exactly. So the very next one is I think our number 1 request feature, which is the ability to configure custom error pages for requests that fail at the front end, right? So if you have a request that makes it all the way to the worker, you can configure a custom error page and have your own branding. So like a good example of this would be a 404. There's some content that's not there. Your web logic can handle that and render a branded page. But if you hit something like a 502, 503, where the request makes it to the front end, the front end tries to find an instance of your app, but your app is not responding, then that request gets terminated at the front end. So today you would get like a generic page that would basically tell you, hey, can't find the app. You can't do anything about it because it's not getting to your code, right? So being able to enable that at the front end tier, so that you can have those branded customer pages, so that you never bleed out the fact that you're being hosted on Azure, for example.
Nice.
If I may
go
ask
ahead.
you a quick question, so the communication between the front end and the worker, is that on gRPC?
So if you're doing gRPC, that flows from the client to the front end, all the way down to the worker. There's a flag that you need to configure on your app that basically flows it all the way down to the worker. If you're doing just HTTP, HTTPS, the request gets terminated at the front end. That's where the TLS SSL offloading happens, and then the rest gets forwarded over to the worker.
Okay.
Over HTTP.
Okay. And the reason I ask is because, I've been debugging some functions apps recently, and I noticed that when there's an error, there is a huge stack trace, and there's a lot of gRPC code at the bottom of that stack trace. I mean, it's, maybe 20, 30 lines of gRPC code, and then on the top, I can see my code, and I always often wonder why there's all that excess in there. But that's not because of the front end, from what you're saying. That's probably just the implementation of the worker.
Yeah, like honestly, I if you're not using gRPC on your code, I don't see how you would see this. But
I think the function
Yeah, it must be a
runtimes,
functions thing.
they may be
Yeah.
wire up the worker. Okay, so
Yeah.
probably something.
Right.
Okay, sorry about that. Go ahead.
No worries. I actually lost track of where I was.
Yeah,
What I
no,
was going to
I
say.
think this is great because I mean this touched on you sort of hit on the thing that blew my mind when you and I first started talking is this is a major, there's good customer reasons to do it. There's good COGS reasons to do it. There's good technical reasons, right? It's easier to debug, all that kind of stuff. But at the end of the day, this is still a non-trivial thing to change this while it's in flight. And you can want to do it all you want, but it still takes that effort to do it. The fact that y'all were able to do this and make this switch, and not saying there's no bugs. So if there's any customer out there that had a Kestrel related bug, I'm not sort of saying that didn't happen. It absolutely did. I've debugged some of these myself, but by and large, for most customers is a fairly seamless process. And now we're running on this new architecture, which unlocks, to your point, new features, new capabilities down the road, and more speed ultimately as well, right? Because it's
Right.
easier for y'all to develop, fix things. You get the benefits of open source and whatnot. So I mean, that's fantastic. Any last messages or anything you want to leave the audience with?
Yeah, I think one of the eye-opening things here was we got deep integration or deep collaboration from the .NET team. So, for example, there's other Microsoft properties that have been migrated to newer versions of .NET. I think like Bing and Active Directory recently did a .NET 6 migration. But the thing in those scenarios is that they have a very controlled client and web server infrastructure, right? It's
because you're
always
not
the
running
same
customer code at the end of the day.
Right, exactly.
Yeah.
Where in our case, we really have no control over what the customer is writing and what are the clients that are calling in. So I think that was an eye-opening experience for a lot of the engineers, and looking at the complexities of, like I said, millions of cores and millions of machines, and how do we do this in a seamless manner so that we don't break random customer that happens to be doing something that is not per the spec, but still works, right? So
And
I think that was one of the biggest enrichment opportunities that we had.
From a customer perspective, they wouldn't know, right, when they were being migrated off, let's say, a Windows front end to, say, yeah.
That's the goal, right? We try to make it as transparent as possible, so that you only find out when you listen to this podcast, right?
And what you were talking about is when I cut you off earlier is how you have those new error pages. I think you said that's the number one ask that you see on the user forum.
Yeah.
Now, and to take that further, though, is there anything else from a troubleshooting perspective that has to be considered with this new front end in place? Like, I know you have like troubleshooters, for example, on the Azure Web Apps service. Do those now talk to this new subsystem? Is that was that all done through and through?
Exactly. All of that is completely like wired through. So any tooling, like, for example, if you're trying to remote debug from VS Code into your app, all of that works. I think it's like as complete as it can get as far as the overhaul goes.
They get that one stamp or somewhere that we talked about, right? That
exactly.
I could just see Byron, going, okay, we done with that one? We done with that? I see a little party being thrown somewhere, right? When that last one goes.
So, I think I need to get some cake when that happens.
Awesome. No, this was great, Byron. Appreciate you. Like I said, it took us a while to find the right time. The fact that y'all are at 100% essentially is a phenomenal achievement. I'm glad you could come on to talk about it, and a lot to think about. Next, when you rip Kestrel out and replace it with something else, in 3 or 4 years, we'll have you come back and talk about that. But definitely appreciate you coming on.
Yeah, I hope you do something special for episode 486. I just see something there.
Awesome. Great. Thanks, y'all.
Thank you, bud.